All right. Good afternoon, everyone. Thanks for joining us on this class. Thanks for interest in this topic. My name is Leo Bastos. I'm going to be your instructor for this semester. And hold on just a second. And well, just the first day of class is always good to check to make sure people are in the right place. So if you're here for the marine sciences studies, you're in the wrong place. This is the programming precision ag course. If you're here for that, then you're in the right place. And we're gonna go through the syllabus today and get started with just understanding how things are gonna flow this semester. So yesterday I sent you all an email with some links. I do want to ask you to keep that email handy because I'm going to be showing you a link that is going to be very, very useful and needed throughout this semester. So if you did not receive the email yesterday with the link, let me know. You're welcome to unmute yourself and speak up. Otherwise, I'm assuming you all have it. So if you open that link, it's going to take you to the screen that you're seeing on my end as well. And so this is my website where I have material, teaching material. I am teaching 2 courses this semester. And so if you come to my website, if you go on the teaching tab, you're going to see 2 active links here under the courses column. If you are taking both of my courses, this is especially important for you to not get confused. If you're just taking this one, then make sure you click on the 2025 Programming Precision Ag and let's go there. I'm going to use this website here to share materials. Yeah.
I was just make sure everything, Leo, right?
Oh, yeah.
Just want to make sure everything was good for you in the AV.
Oh, yeah, it's running smoothly.
Running
Yes,
right,
no
okay.
problem. Thank you. All right, so getting back here, so this website is where I'm going to share with you a lot of the material for the class during the class as well. And I just want to quickly show you some points of this website. So first off, all of the code that we're going to be developing and co-developing during the semester is going to be distributed through a GitHub repository. Here's the link for that. If you've never used GitHub before, don't worry, we're not going to be using in any complex way, but it's just one place where I will share the material, the partial field codes and the data sets that we use through the semester is going to be through here. And the link for that again is on this page, this web page here. Also, every class period is going to be recorded, and within 1 hour of the class ending, I will be posting that recording to my YouTube channel, where you can catch up later with the recording if you wish. If maybe you were in class, but something was not quite clear and you just want to take another look at it, or even if you have to miss a class and then catch up through the entire video afterwards, they're going to be posted on this YouTube channel here that I control for your use. All right, getting back here. On this web page, you're going to see the schedule of our classes. This schedule here is something that I have planned, but we may have some small changes throughout the semester depending on the speed that we're moving and the topics that you're all interested in as well. But just as a rule of thumb, just so you see here, we have the dates, the time, we have the topic that's going to be covered under this column. If there is a homework due, the due date, the homework is assigned on the topic column and the due date is going to show up on the homework due, so you can track that. If during that class there was any PowerPoint slides like there will be today, then the link for the slides is going to be active. If there's no active link, it's just because we didn't really had a slide set for that class. Whenever I introduce new partial code, there's going to be a link connecting that right here. This will become active. And then every class will have a recording. So there's going to be a link for the recording here as we develop those classes and recordings throughout the semester. Also, so if you go through here, you're going to see our initial plan, at least, of all the topics that we're going to cover, when there will be assignments, and so on. After this, there's the full course syllabus. I'm not going to go through with you here on this web page on every small detail. I do encourage you to go through it if you want to have a full picture of what we're going to be doing, what I expect of you, and what you can expect of me. There's a lot of information here. And at the end, I have some resources to some links of things I find useful when programming in R, especially related to Precision Ag. So if you're interested, there are some resources there. All right, so for today's class, again, my goal is going to be to walk you through some key highlights of the syllabus. And we're going to do that through this PowerPoint or this slide set that I have right here. If you are on the website, you can actually click on this. It's going to launch a new tab for you. This is an HTML slide deck. And so you can follow through there, or you can just watch on my screen. You can also do that if you want. All right, so on my side here, I'm going to just walk us through. If at any point you have any questions about what we're talking about, feel free to interrupt me. Feel free to unmute yourself. I do welcome questions at any time. All right, so again, welcome to the class. I think that we did not have any undergrad this semester enrolled. And I think that's, this is a split level course that accepts both undergrad and grad students. I don't think we had any undergrads, which is a good thing for the graduate students because then you can use this as a graduate level course in your program of studies. So just a heads up. All right, so this semester, the teaching team is going to be comprised by me. So Leo Bastos, I'm an assistant professor of integrative precision ag here at UGA. My office is in Athens, on the Athens campus on 4101 Miller Plant Sciences building. If you are not here in Athens, if you're watching this class from another campus and you ever stop by Athens, make sure to stop by my office, say hi. I really enjoy meeting students that face-to-face, especially students that are not here on the Athens campus. And then this semester, we're going to have a teaching assistant. So Nushrat Niva, she's here in Athens. So for those in Athens, you can get support from Niva in person. For those of you in Tifton, you can schedule a Zoom call with her. She has taken my course before, so she's very well versed on these topics. She's also a PhD student with Dr. Lacerda's lab, also involved in precision ag. So she has a lot of experience, and I'm very excited to have her as part of the teaching team this semester. All right, let's talk about office hours. So Niva is going to have some office hours on Monday and Thursday from 9 to 11 a.m. upon appointment. What do I mean by that? So Niva is going to be available to help you with any questions you may have related to the course on those days, during those times, but she's not going to just be sitting in her computer waiting for someone to show up. So if you do need Niva's help, the way that this is going to work is you email Niva and schedule a time with her during that window on Monday or Thursday from 9 to 11 a.m. And she will be able to connect and help you out. If you have any issues with code or software, really anything that you may need help with in relation to the course. However, and I do have a however here, is that we're going to talk more about this in a moment, but anytime you have questions, I do want you to first use GitHub before you go to Niva. And we're going to talk about this in a moment, but for now, I just wanted to have this however here, that Niva is a resource and she's going to be a resource. I am also a resource that will be available for you but we have a sequence of events for us to go through when we need help. And that is both to help us all to be more efficient, but also to help students to learn how to troubleshoot on your own and being independent in that sense. Since every time we're coding, we're always going to get bugs. We're always going to need to debug code. So it's a good skill to develop as well and not just rely on someone else to help you out. All right, so let's do a quick rundown of the syllabus. If you are following this presentation on your computer, and every time you see something in blue like this, it's an active link. You can click here, it's going to take you to the syllabus. I'm not going to do that, but just so you know. All right, so this is a very important thing that has changed, and I need to be very clear and get your feedback as well. So initially, when I submitted the times for the class, they were not the correct times, and so we fixed that. So the class times are going to be Tuesday and Thursday, just like before. They're starting at the same time that you have on your side, but they're ending a little bit later. And this is to make sure that they match the credit hours that this course has on the books. So Tuesdays from 2:20 to 4 p.m. These are going to be our lectures. From Thursdays from 2:20 to 4:20 p.m. This is going to be our labs. I do want to take a quick moment here and open the floor because I know that this change may or may not affect some of you with your schedules of other classes and other commitments. So if this does interfere, this change, this increase in the length of the class period interferes with your schedule, please let me know. And you can let me know now if you want. You can let me know by email, but we can address this and make sure that you don't get late, or that we can accommodate this in your schedule for sure. So just as a quick, I see somebody raising hands in Tifton.
Yes. So the labs won't be anymore in the morning as it was written in the syllabus.
So I believe the syllabus that you may have seen was from last semester.
Okay.
The labs were in the morning then, but this year I guess they should have been listed being in the afternoons from the beginning. So that should not have been different, although I guess it was, right? So if you saw that on a previous version, is that something that will conflict with your schedule?
No, I was just asking.
Awesome. Yeah, anyone else with any questions, or maybe if these conflict with your schedule and if anyone wants to bring that up now, we can have a quick chat. All right, I don't hear anything. I just want to say that if this does conflict with your schedule, do let me know by email today, and we can try to find a way to accommodate for that. And if not, then even better that it's not going to interfere with anyone's schedule. All right, so just to recap then, our lectures on Tuesdays from 2:20 to 4 p.m., our labs on Thursdays from 2:20 to 4:20. I just want to say something very quickly here that even though we're calling lectures on Tuesdays and labs on Thursdays, this really does not make any difference. About 90% of the time, we're going to be live coding in class, and regardless if it is a Tuesday or a Thursday. So, I guess this is just how it's called behind the scenes, but we're really going to be doing hands-on exercises most of the time, regardless of the day of the week. All right, so as far as location, for Athens, it's in person here at 1203 Miller. For Tifton, it's going to be in person at 601 Naspel South or remote. For Griffin, I don't think we have any Griffin, or perhaps I could be mistaken. Kiathi, are you in Griffin or Tifton?
I'm from Tifton, Professor. I had some work today, so I have to stay in my labs.
Okay, no problem. All right, so with that, we really don't have anyone from Griffin, so I'm just going to skip that. And also, as you saw, the Zoom credentials are shared by email through ELC, so we have that information there. I'm not going to be sharing that link in my website. All right, so let's just go through some of the course objectives. It's one of them. The first one here is to obtain, process, and use various ag geospatial data layers for decision-making related to precision ag. We have a couple of examples here where the first one on the left is just a raw yield monitor data from a cotton farm in Georgia. We see a lot of spatial variability. That's really great. That's what we use to learn and to make decisions about that variability. On the right, you see an elevation map of that same field. So we're going to be working with, these are two examples of layers we're going to be working this semester. We're going to be working with a lot of different data types, and that includes both public data and proprietary or private data. On the public data side, we're going to be working with weather, soils, and satellite remote sensing. From the private data side, we're going to be working with yield monitor data, soils, and UAV remote sensing. Here's just a few examples of that. On the left, we have a green NDVI maximum value map across the growing season for that same field. In the middle, we have a interpolated yield monitor data for that same field. And then on the right, we have the soil electroconductivity interpolated map for that field as well. So these are some of the layers that are very common in precision ag. We see that very commonly growers collecting this type of data, using this type of data. So it's very applicable for precision ag. So we're going to have all this data, and we're also going to explore this data using different approaches, right? So that's going to include analytical techniques for creating management zones, creating zone-based and imagery-based variable rate prescription maps, profitability maps, and then using satellite remote sensing for crop scouting. Here are a few examples. On the far left here, we have a zone-based prescription of nitrogen for that field that we're seeing here. In the middle, we have a profit map for this field that takes into account both the yield, the price of that crop, the rate of input, and also the cost of input. And then on the far right, we just see an animated map of a green NDVI for a cotton field as well over the growing season. So we can really use that for scouting, identify areas that are starting to fall behind. All of this is going to be conducted utilizing the R statistical language. So we're going to be using programming for doing all this, as you may have guessed from the course name, to create modern, well-documented, and reproducible precision ag analytical workflows. If you've never worked with R before, that's not a problem. That is not a requirement, but I will assure you, you're going to learn a lot of R by the end of this semester. So in R, we're going to be using some packages that are very useful. Well, first off, we're going to be using R within RStudio. RStudio is just a tool that we're going to use to bring together a lot of components of an analysis into one window, one software. If you've been working with R in RStudio, RStudio was the name of the software and also the name of the company. And about few years ago, the name of the company changed to POSIT, but the name of the software remained the same. So just so you understand some of the dynamics of that name. So RStudio is the software that we use, and the company name has shifted to be called POSIT. And within RStudio and POSIT, they have developed a lot of packages in R that they make up what is called the tidyverse. And the tidyverse is just a collection of packages that we use for data science in R, and is really the state-of-the-art level of functions in R to use for really any application that also includes precision ag. So we're going to be using packages like dplyr and tidyr for data wrangling, using the pipe operator, using Tibble for data frames, ggplot2 for plots, and so on. And also we're going to be using the SF package for geospatial vector layers manipulation in R. So a quick example of what we're going to be doing this semester is basically going from raw data all the way to creating a prescription map based on zones and everything in between. So what we see here on the top is just unclean yield data with a lot of erroneous data points that have to be removed, that clean yield data after removing those data points, and then combining multiple years of clean yield data to create a spatial temporal stability classes of yield in this field, and then creating zones based on elevation, slope, and aspect, and also electroconductivity at shallow and deep layers, combining all this to create zones, and then using those zones to create a variable rate prescription of a given input. In our case, is going to be nitrogen. Some of the course topics that we're going to go through is intro to R. So this is really to help to catch up. If you have not used R in the past, you can catch up, and we can always start at a similar level. We're going to use R as a geographic information system. So we're going to talk about that. If you have used other GIS in the past in different classes, it may have been a point and click software. So now how do we translate those functionalities to a programming language? We're going to be accessing publicly available geospatial data through R. This includes soil, it includes satellite remote sensing and others. We're creating grids for soil sampling, making interpolation, process EOMonitor data, process terrain data. So this is related to elevation and other secondary variables that we can derive from that type of data. Creating management zones. We're going to do a little bit of UAV remote sensing. So this class, my class, the one that you're attending right now, our goal is just to take a UAV imagery that has already been pre-processed and then use that for an applied purpose. We're not going to be going through collection of imagery from UAVs or the pre-processing as far as ground control points and creating orthomosaics and fixing for reflectance or creating reflectance maps based on radiance. We're not going to be doing that. Dr. Lacerda has a great course on that she teaches in the fall. So if you do want to know more about the pre-processing steps of that workflow, Dr. Lorena's course is the one to go. Here, we're just going to have one exercise where we're going to be using a already processed UAV imagery for variable rate management. Then creating a variable rate prescription, working on profitability maps, and then pulling satellite imagery. In our case, is going to be for crop scouting and also determining spatial variability in the field as well. But really, the key is just learning how to pull open source, or not open source, but for research, open source satellite imagery that we can use for different purposes. All right, so we briefly talked about this, but all classes will be recorded and further posted on the class YouTube channel. But I do want to make clear that this should be used as a supporting study tool. And in case you have to, miss a class, you can catch up with the video. But the recordings do not replace in-person or remote attendance. You still have to attend live unless a special circumstance happens, and then we're going to talk about those cases in a second here. All right, so here's how your grade is going to be broken down. We're going to have a mini project that involves pulling data from USDA National Agricultural Statistical Service. They have a lot of really interesting data. We're going to be pulling data from there and doing a mini project based on that geospatial data. We're going to have a midterm exam. We're going to have about 8 homework assignments, in-class quizzes, a final project that I'm going to hand you some new data, and you're going to have to basically reproduce everything you learned this semester on a new set of data. And then class participation being 10%. Something I want to make clear is, of all these projects, exams, assignments, the only thing you cannot make up for is in-class quizzes. What do I mean by that? If you perhaps have to miss the class that, it was the midterm exam, for example, as long as we communicate before that and we understand the circumstances, I am flexible. I have no problem. If you need an extension on a homework assignment because of whatever reason, we can talk about it, we can get to an agreement. So you can make up for all of these except in-class quizzes. In-class quizzes are going to be very short, fast quizzes that I give in class. You don't know, you're not going to know when it's going to happen. And that's the goal. The in-class quiz goal is to make sure that you are following, you are paying attention, you're engaging, and you are absorbing the content. And so if you're not in class, then you cannot really make up for it. So just a heads up on that side. All right, so a few important links for this course. These are all hyperlinks. So if you're following on the online version, you can click on these. So again, we have the course website, the GitHub repository, and the YouTube channel. These are just, again, the links for you in case you want to have them for a reference. All right, so as you're seeing, if we have slides, it's going to be on this format. It's going to be on HTML format, which, it's not really easy for you to take notes on that. So I want to show you a way on how you would download these HTML slides as a PDF, and then you can take notes on your computer or maybe print if you wish, and take notes manually on your side. So the instructions here are on your keyboard. You push E on your keyboard. That will change the slides to a continuous scroll rather than passing slides with arrows. Once you do this, at least on a Mac, you will come to File, and you can export or print. Let me see what were my instructions here. Let me come back. Yeah, so you can go to File and Print. You can adjust the orientation of the pages if you wish, and then just save as a PDF. So this way, for every time we have a lecture like this, like the slide sets like this, you can download that and take notes on your side if you want. All right. So let's talk about asking questions and support. If you have a question, and you will have questions, you will have issues with your code, with maybe software, installing packages, installing RStudio, all these things. These will happen. It's common. It always happens. It is expected. And so if you have a question that's related to difficulties with the material, with the code, or with assignments, the first place I want you to seek for help is going to be on the GitHub repository of this class under the Issues tab. And I'll show you what I mean by that in a second here. Also, something else I wanted to let you know, the structure of seeking help that I would like for you to follow is actually the following. If you run into an issue, the first thing that I would do is Google it, right? How to do X in R, or I got this error in R, what to do, whatever it is, right? So Google it. If you want to use ChatGPT or other AI tools for that, you can use that as well. What I'm trying to say is the first search for help that you should use is your own resources that you already have at your disposal, like Google, ChatGPT, and so on. If none of that worked, then the next step is I would like you to ask that question of whatever issue you're having in our GitHub repo under the Issues tab. Why is that? In the past, when I did not do this, I would have students, maybe 3-4 students emailing me separately with a very similar question. So I would help each one of them, but it was not very efficient on my side. Also, if you post on GitHub what issue you're having, maybe one of your colleagues have had the same issue, have already found a solution, and can help you out. So this also helps on your class participation. Both asking for help on GitHub and helping others when they ask for help and you know the answer counts towards your class participation. So I do want to make that clear. All right, so whenever you are ready to use GitHub to ask for help, you would go to the GitHub repository of this class. So this, if we're following the live presentation, this is a hyperlink. You can click on it. So let me go there. So I clicked on it. It took me here. So Leo and Bastos 2025 PPA, right? So this is how GitHub looks like. On the top, there is an Issues tab, as you can see right there. If you click there, this is the Issues page. So whenever you have issues, what I want you to do is come here, create a new issue, give it an informative title, perhaps like issue or problem error importing data into assignment 1 or something like that. And then describe your problem below here. When you describe your problem, it's probably going to be useful for you to include a screenshot of both the code, the error, and the output you're getting in case that is where the issue is happening, so people can see what's going on. You can also include code if you want. This is an HTML markdown type of file, so you can include your own code here if you want to show, instead of as text, showing as code. Anyways, you just describe your problem right there. Oops. And then you submit that new issue. Everyone that is following that repository is going to be notified, and then people can help you with that. So sometimes, I will be prompting each one of you to help me out in class. So I'll be asking you questions. I'll be prompting you to get your thoughts around something, each one of you. However, you may not be the type of student that likes to ask questions in class. Maybe you like to ask questions by email or GitHub, like I'm proposing here. And asking questions and participating is going to count your 10% class participation portion of the grade. So especially if you don't really enjoy speaking in class, make sure you use GitHub to your advantage, as that counts as participation. However, even if you do ask questions in class, I also encourage you to use GitHub, as that counts as participation across the board. So just make sure that you use that resource that you have there. All right, so let's try it out. I will create an issue on our GitHub repo called introductions. And on your side, I want you to respond to that issue. For that to happen, you're gonna have to have a GitHub account. If you don't have one yet, please go ahead and sign up for one. It is free. And once you sign up, I want you to respond to my introductions issue by telling me your first and last name, your department, if you are pursuing a master's or a PhD, and what is your area of research. So I'm gonna go there to our github.com/Leo M. Bastos/2025_PPA. This link here again is in our website. It is in the presentation. So if you need to find the link, those are the places to find. I'm gonna come again here under issues. I'm gonna create a new issue. I'm gonna call the title introductions. And I'm gonna fill up here my response. So Leo Bastos, I'm in the crop and soils department. I am not pursuing a degree anymore, so no degree. And my area is precision ag. I'm gonna submit this new issue. And now if you go on the issues page, you're gonna see there is an open issue called introductions. I want you to come and respond to this issue with your information. Do not create a new issue called introductions, okay? So when you go on issues, do not create a new one. Just open this one that I created and just respond under it with your information. I'm gonna give you all a quick moment here, especially in case you need to sign up to GitHub or whatever else may be. So I'll give you a moment. If anyone has any questions or problems, let me know and I'll be glad to help you out. All right, I think we got everyone in. We have 6 students enrolled. I think that's it, right? 2, 3, 4, 5, 6. Yeah, I think we got everyone in. Well, thanks. So that would be how you would respond to a GitHub issue, right? You just come under an issue and answer it. Of course, in this case, I was not asking you for help, but that's the overall idea. Every time you see an issue open, is because someone is asking for help around a given topic, and you can jump in and help them there. All right. Let's talk about attendance policy. So I do expect all of the students to attend every class period. The students here on the Athens campus must attend class in person. For students in any of the campuses, if a special circumstance arises, you should let me know beforehand, maybe a day before. If you know you're gonna be away on a conference or you're sick, you cannot come to class, whatever it is, if you notify me the day before, you will be excused from that class and it will not count as a missed class for you. But we do have to have that communication channel there. For students in Tifton and Griffin, you can attend in person on your campus where you are right now on your computer lab or remote. So let's say if you want to attend from your office or perhaps you want to attend from home or whatever it is, you have the option of attending remotely. Athens only option is in person. Tifton and Griffin can be in person on your campuses or remote. For Tifton and Griffin, I do encourage you to attend in person on your computer labs because it's going to be very helpful to have other people by your side that are going through the same exercise in case you run into issues, and you will. So I do highly encourage you to attend in person. However, you do have the option of attending remotely if you wish. If you're in Tifton and you do decide to attend remotely, you do not have to let me know. I'm not gonna, that is not something you have to inform me. However, if you are in Athens and you are attending remotely for some reason, you do need to let me know because in Athens, I'm expecting in person since I am teaching in person from Athens. Punctuality is going to be really important for this course, as you're going to realize very quickly once we start coding. We will be coding for most of the time in this class. If you miss a couple minutes in the beginning of the class, you may not be able to catch up for the remaining 2 hours because of 2 minutes you miss in the beginning. So make sure you are punctual in class. You come and you're ready to go at the time that we start class at 2:20. If a student is more than 3 minutes late and I notice that, I will ask that student to leave and that will be recorded as a missed class. The reason for that is I've been more lenient in the past, and what I notice is if students that come in late, they disturb the class, they ask for their colleagues for help to catch up, and they disturb their colleagues that are next to them because of that. So it just creates a lot of chaos, and I want to avoid that. So the point is, make sure you're on time. If you cannot be on time, like your bus is late, it's raining, it's pouring outside, it has snowed, you cannot come into class, just let me know before class. We can always, I'm very flexible as long as we communicate. So if you give me a heads up, hey, I'm gonna be late, just give me a heads up and we can go from there. But if you just are late without giving me a heads up, I will ask you to leave, and that will be counted as a miss on your side. All right, so we've been talking about, being excused from missing a class, missing a class. What is the difference there? So here's the case. If you let me know that you cannot make the class, I will excuse you from that class. You're not going to be recorded as a missed class. However, if you just don't show up, you don't give me a heads up, you will receive a miss. And then you have a total of 5 misses during the whole semester you can take. Any student that takes more than 5 missed classes without giving me a heads up beforehand, I have the right to drop you from class and give you a WF grade, which I don't want to do. So just make sure that you either come to class on time, and if you cannot make it to class, just let me know beforehand. As long as we communicate, I'm very flexible. All right, if you are attending online, meaning either from the Tifton campus or maybe remotely from your home, office, wherever that may be. I do expect cameras on at all times. That counts as part of your participation as well. If you have your camera off, I will call you off. And if you don't turn it on, that will affect your participation grade. So just make sure you have your cameras on, and that should be all right. All right, when it comes to technology and software requirements, each one of you will need to have a couple of things. A computer, right? You are in a computer lab, and you are welcome to use the desktop right in front of you. However, I do recommend you use your own laptop or your work laptop. The reason for that is we're going to be installing a lot of software, right? So R Studio, a lot of packages, a lot of things that we will start building up on the computer that if you install on your laptop, you have already all that library of software installed, after class to use on your projects, to use on your research, to use on future classes or whatever it may be. So if you don't have a personal laptop or a work laptop to do this, you're welcome to use the desktops right in front of you, but I do recommend you use something you can take with you outside of class. And then, especially if you're attending remotely, you will need a second screen. If you're attending in person on our campuses, you have the projector screen right in front of you, so you do not need a second screen necessarily. But if you're attending remotely, you will need a second screen. The goal here is that you use your computer to code along with me, and then a second screen to see me, right? So you need to see what I'm doing, the code I'm developing, and you need to develop that yourself on your computer. So one computer, you write the code, the other screen is where you see what I'm doing if you're not on campus. If for some reason you do not have access to these resources, do let me know. We can work and help you figure out and accommodate your needs. So yeah, if you need help around this topic, please let me know by email. And if not, then I just assume that everyone has access to these. Okay, so these days, a lot of AI and chatbots and large language models are coming into our lives. So I just want to have here very clear what is my policy for this course. You are allowed to use large language models like ChatGPT on your coding assignments, as long as you use it to learn, not just to copy and paste. I myself have used ChatGPT to help me with code in the past. It is really powerful. It is really useful. However, for the most part, what I was asking ChatGPT, I already knew how to do. I just needed it to be done more efficiently and faster, which was the case. On your side, if it is something new for you that you've never done before, and you ask ChatGPT to give you the answer, and just copy and paste and run on the assignment, it is not helping you. You're just fooling yourself, right? You're not learning how to do, you're not learning what each line of code is doing, and that is just not useful for you. If that was your goal, then you didn't really need to take a class, right? You could just ask it right off the bat. So I do ask that you can use these tools for a benefit, but make sure you learn from it. Make sure you understand what each line of code is doing, and not just simply copy and paste from ChatGPT. And also, if you do use ChatGPT, I ask you that whatever assignment you're using it, that you let me know, give it appropriate credit. Tell me in your assignment, part of my answers or my coding answers were based on ChatGPT. I have no problem with that. That's not going to impact your grade. I just need to know. And the reason for that is because plagiarism, which includes from chatbots or any other type of plagiarism that we already know, like just copying and pasting from Google or maybe from your classmates, is a serious violation of code of conduct, and I will report to university officials if that happens. So it's very easy to avoid that happening. You can use ChatGPT. You just gotta let me know that you used, and then we're all good. All right, so now I have a survey for you all. This is a link, it's a hyperlink. So if you're following the HTML on your side, you can just click on it. I'm gonna copy this and also paste in the chat in case you need a link for it. And you can access the chat. So just paste it there. This is just a survey that's gonna help me understand your familiarity with some of the tools and also some of your interests so I can gauge the course content to our classes specifically. So I'm going to give you 5 minutes here to answer that. Let me put a timer for 5 minutes here. And please go ahead and answer that survey. I'm going to go back here to the survey so you can see the link, but please go ahead and answer that survey. All right, our time is up, but I think I only got a few answers. I'm just gonna give another minute here for answers. Just gonna give another minute for a couple of students to finish, and then we'll keep going. All right, I think everyone responded. Thank you all for responding. I'm gonna use your answers again, both to gauge your interests, your backgrounds, and some of the activities that we'll be doing this semester. All right, so next class, so that's gonna be on this coming Thursday. We are gonna do an intro to R exercise. With that exercise, you need to do some prep work on your side before the class. So for you to be ready for Thursday, I do ask you to, so if we go back here to the class website, make sure you're on the Programming Precision Ag page. There's a Lab 1 prep right here that I want you to open that and follow those instructions. So these are basically, if you have not done, well, some of these steps I think you're gonna have to do regardless, but some of them you may skip depending on your previous use of R and R Studio. So if you've never used R and R Studio, then you're gonna have to install R Studio, download class material from GitHub, install some packages based on that material. And I believe all of you already signed up for a free GitHub account, but if you have not, then you have to do that as well. I do have a video showing all this, and I have instructions on installing R Studio, how to download material from GitHub, how to install packages. There are some instructions here that you can follow. And then, I think in step 5, you all have done already. So all this should happen before class next Thursday. I would encourage you, so we have here until our class goes until 4 today, and we have here about 40 minutes left. What I would encourage you is especially if you have not installed R in R Studio before, do take advantage of these coming 40 minutes to go through these in class. Because if you do run into issues, I'm going to be here until 4. Neva is here in the room until 4 as well. We can help you out with this. And even if you already have R in R Studio, we're still going to have to download material from GitHub, install packages, and that's going to be it. So I do encourage you all to go ahead and do that during this coming 40 minutes here that we still have left. And if you run into issues, we can help you out. Once you have completed all that, this is pretty much everything I have for you for today. So once you finish that, you are dismissed from class. And before we go on that mode, I just want to open here and open the floor for any questions. So anyone has any questions about the syllabus, about what I expect of you, what you can expect of me, or anything really related to what we just talked about. If you have a question, feel free to unmute yourself and just speak up. All right, so I don't hear anything. I'm assuming you are all good. So what I'm going to do from my side is I'm going to stop the recording. But I'll be here. I'll be on Zoom to help you to conclude these steps if you need help with. But I'll just wrap up our recording here.